EMD Electrical Machine Design Transformers. Design of transformers. Our aim is to obtain the following information regarding its various circuits using the given specifications and selecting proper materials for various parts. Main dimension of the magnetic circuit, that is core, yoke and window. Design details of electrical circuits, LV and HV windings. Performance characteristics: no load current, no load power factor, iron losses, copper losses, efficiency, maximum efficiency, load corresponding to maximum efficiency, percentage of reactance, percentage of regulation, short circuit current, and short circuit power factor. Fourth point, design details of tank, that is main dimension of tank, number of cooling tubes and temperature rise. Requirements for design: detailed specification of transformer, limiting values of performance characteristics, various design equations based on which the design procedure will be initiated, the various equations for design. First equations, that is output equations. Second, equations of EMF and EMF per turn. Third, equations of percentage of reactance and regulation. Fourth point, equations for temperature rise. Information regarding the choice of various design parasite. First point, specific magnetic loading. Second, current density. Third, Windows phase factor, Ka for step. Information regarding the level of insulation at different places between core and LV, between LV and HV winding, between yoke and winding, etc. The transformer consists of yoke and windings, HV and LV windings, and core. Information regarding materials available for various parts so that the designer can choose better one. Specifications: first, rated output in kVA or MVA. Second, rated voltage ratios. Third, frequency. Fourth, types of transformers. Fifth, number of phases, single or three phase. Sixth, connections, star or delta. Seventh, class, power or distribution type. Seventh, eighth, type of cooling, dry type and design equations. First, EMF equation. Induced EMF in the primary winding E1 is equal to minus capital T1 d phi by dt, where flux phi is equal to phi m cos omega t. E1 is equal to minus T1 d by dt of phi m cos omega t. That is, E1 is equal to T1 omega pi m sin omega t, when omega t is 90 degrees, sin omega t is equal to 1. E1 maximum is equal to design equation, EMF equation. E1 max is equal to T1 omega pi m. RMS value is E1 is equal to T1 2 pi f into pi f divided by root 2. E1 is equal to 4.44 f pi m. E1 is 4.44 f T1 pi m. E1 is equal to 4.44 f T1 bm ai. T1 is number of turns of primary winding. T2 is number of turns of secondary winding. Pi m is maximum flux in Weber. Bm is maximum flux density in core. F is frequency of supply in Hertz. Ai, net cross sectional area of core in meters square. EMF per turn, ET is 4.44 f pi m. kVA per phase is equal to VA into 10 power minus 3. That is equal to V divided by T into IT into 10 power minus 3. That is equal to ET into IT into 10 power minus 3. The ratio of cross-sectional area of core and copper area of winding will be constant for a particular transformer. AI divided by AC is equal to constant. That is, AA is equal to pi m divided by Bm, and copper area of the winding in AC. Del is current density. AC is AT. that is equal to AC is equal to I divided by del into T. AA divided by AC is equal to pi m divided by IT into del divided by BM is equal to constant. AC is area of core. A is net cross-sectional area of core in meters square. kVA reading per phase is equal to ET into IT into 10 by minus 3. That is ET into 5M divided by R into 10 by minus 3. Where pi m is equal to kVA divided by per phase into R divided by ET into 10 by minus 3. That is QR divided by ET into 10 power 3. That is pi m value is formula is equal to Q into R divided by ET into 10 power 3. Phi is flux value. ET is EMF value. Turns value. T is R is radius. ET value is equal to 4.44 F pi m. ET is equal to 4.44 F into pi m value is kVA per phase into R divided by ET into 10 power 3. Above formula we find out the pi m formula. ET is square is equal to 4.44 F or into 10 power 3 into kVA per phase. R is pi m divided by IT. IT is equal to pi m divided by R. ET is K into kVA per phase. That is ET is equal to capital K root of Q. That is very, very important equations where K is root of 4.44 F into R into 10 power 3. ET value is K into root of Q. R is equal to pi m divided by IT is constant. K depends upon the ratio AA divided by AC. Tabulation we see next page. Type of transformer. Very, very important equations is ET tabulation, is equal to K type of transformer per phase and value of K. Single phase shell type value of K is 1 to 1.1. One single phase core type 0.75 to 0.8. Three phase shell type 1.2 to 1.3. Three phase core type. Distribution transformer 0.45 to 0.5. Three phase core type power transformer 0.6 to 0.65.